These twin eyes are preparing to look into deepest space. They belong to the Large Binocular Telescope. It is one of the most powerful telescopes on Earth, costing over $120 million. These 28-foot wide mirrors collect light from objects millions of times fainter than anything our eyes can see. 600 tons of machinery turn the mirrors to look more than 13 billion light years away, to the very edges of the visible universe. Super telescopes like this are taking real images that illuminate the darkest corners of our skies. Billowing clouds of gas and dust are buffeted by supersonic winds and lit up by thousands of energetic new stars. 57 trillion miles high, these giant clouds of gas and dust are stellar nurseries, hiding the very birthplaces of stars and planets. Suddenly, a star's explosive death sends its superheated gas ripping through space at hundreds of miles per second. And in faraway galaxies, we can take images of invisible jets of energy screaming out from one of the most mysterious objects, a supermassive black hole. All because of high-tech telescopes.
The telescope has changed the way we as a species think about ourselves.
With a new telescope, you're always going to find something new because you always add to your ability to see more.
These breathtaking images are only possible because extraordinary telescopes like these are staring out night after night across the globe and in space. Over the past 4 centuries, revolutions in technology have transformed this groundbreaking instrument. So where did it all begin? The journey starts with one man and 2 pieces of glass. It is the summer of 1609. Mathematics professor Galileo Galilei is building his own version of an extraordinary new invention. It is the telescope, a name that means far-seeing in ancient Greek. The invention has spread like wildfire across Europe from a small town in Holland. Spectacle makers working on the most precise glass lenses of the day discovered that 2 different types of lenses held at just the right distance produce a surprising optical effect. They act like a magnifying glass for distant objects. This is the birth of the telescope. Galileo immediately sees the potential of the invention.
Galileo is a practical mathematician. That's his trade. He designs instruments, he teaches the use of these instruments, and these instruments are often used for warfare.
Galileo works out how to increase the magnifying power of the telescope to 8 times what our naked eyes can see, and he hits on a military use for it.
And it would be particularly advantageous if you could see the enemy before he can see you.
The Venetian military buys this new device as a spyglass for spotting enemy ships. But then, Galileo turns his telescope from the Earth to the sky and starts a revolution.
By turning the telescope to the heavens, Galileo enters a whole new regime of practice there, where this instrument can be used to discover things we didn't know before about the world.
All astronomers knew of the heavens before Galileo was what they could see with the naked eye, the stars and the moon. But today, even amateur astronomers can see much, much more. Alexandra Hall spends her nights gazing up at the night sky from her backyard.
I never get bored of looking at the night sky above our heads. It's like 2,000 diamonds sprinkled across black velvet. And then the moon arises, and watching the moon go through its phases, I mean, it looks different every time you look at it.
To the naked eye, 5 stars sometimes appear brighter than the rest, and watched over the course of nights, they seem to move against the backdrop of the other stars.
And they don't just stay in the same place like all the rest of the stars. They move around. Sometimes they're visible, sometimes they're not.
Each of these bright stars is a planet, a name that simply means wanderer in Greek. Venus, the evening star, skims the horizon at sunset. Mars glows red. Jupiter and Saturn outshine everything around them. We now know that these wandering stars are actually other worlds, like the Earth, planets as we understand them today. But in Galileo's time, everyone believes they are just stars. There is only one world in the universe, our Earth, and it sits at the very center of everything. The sun appears to circle the Earth during the day, and over the long course of the night, the moon and stars also appear to rotate across the heavens, circling the Earth in giant orbits.
When you stand outside, even just for a few hours at night, you suddenly notice that all the stars, and the planets and the moon, everything is wheeling around your head. It's like you're at the center of things. Really quite a powerful feeling.
But Galileo is about to show that this is just a feeling. He starts to shake the known world order when he looks at the moon. The belief in his day was that all the heavenly bodies were flawless.
In the old cosmology, the moon was a heavenly body and therefore perfect.
But looking across 250,000 miles of space, Galileo sees something very different from the smooth sphere he expects. He sees instead a moon scarred with craters and valleys.
It must have been an extraordinary moment for Galileo to peer with his little itty-bitty crummy telescope at the moon and see craters, mountain ridges, valleys. He saw for the first time geographical terrain on another astronomical object.
This means our Earth is not unique in the cosmos.
These patches that you see are mountains. The moon isn't smooth. It's like the Earth.
But this is just the beginning. Next, Galileo turns his telescope on Jupiter, one of the wandering stars. He sees it as no one has ever seen it before. This is an exact computer reconstruction of what Jupiter looked like through Galileo's telescope. Calibrated on Galileo's actual lenses, it shows what a challenge he faced. A replica of his telescope reveals how hard it is to get a still image.
Well, when I actually got Jupiter in the telescope, it was really difficult to focus because the lens quality is not very good compared to the lenses that we would get today.
To the naked eye, Jupiter looks like a bright star, a spot of light. Seen through Galileo's telescope, all other stars remain as spots of light. But Jupiter suddenly appears as a much larger round disk. This blurry, shaky view of Jupiter is a revelation. Galileo comes to an extraordinary conclusion. Jupiter must be a sphere, another world, a planet as we understand it today. And around it are even more surprises.
Picture yourself, you've just glued a little piece of glass on the front of a long tube, and to your utter surprise, you see 2 or 3 or maybe even 4 stars next to Jupiter, like little ducklings following a duck.
Night after night, Galileo notes the changing position of these new stars.
Imagine your surprise. Why should stars be following Jupiter? And of course, Galileo learned only after a week or two of watching those little ducklings following their mother that those, in fact, were moons orbiting Jupiter.
Galileo knows he has something spectacular on his hands. He publishes his findings in a book called The Starry Messenger.
It is the most explosive scientific book ever written. Its impact was immediate. Galileo became a superstar overnight.
But the biggest revelation is yet to come. Galileo is recording something that will change our view of the universe forever. He observes the planet Venus changing shape and size over a period of months. As Galileo watches, Venus transforms week after week from a large crescent to a small round disk. Then shadows creep again across the planet, returning it to a large crescent. To Galileo, the pattern of shadows he sees on Venus can only mean one thing. Venus is going around the sun. But the belief at the time was that everything circled the Earth. Earth is no longer the center of the cosmos.
And so it said to us, wow, we're not at the center of the universe anymore.
These very simple observations literally rock the foundations of the world. No longer is the Earth the center of the universe. The sun is the center of the universe, despite what our ordinary senses tell us.
But these discoveries famously bring Galileo into direct conflict with the Roman Catholic Church. The Church taught that God placed mankind on Earth at the very center of creation.
Defending a sun-centered universe, Galileo was actually challenging the authority of the Church. He was contradicting what was considered as the legitimate interpretation of the Bible, and the Church couldn't tolerate this.
But what Galileo saw is the solar system we understand today.
The discoveries that Galileo made, they changed the world forever. The world of science, the relationship between science and religion, and the universe forever.
This is the universe Galileo helps reveal. Planets and their moons orbiting the sun. Telescopes today now reveal this solar system in detail that Galileo could only dream of. Explosions on the surface of the sun, the power of 1 billion megatons of TNT. Features in the Great Red Spot on Jupiter, a vast stormy vortex large enough to swallow 3 Earths. On Jupiter's moon, Io, we can watch volcanoes spew ash and gas high into space. On Mars, a canyon 5 times deeper than the Grand Canyon. And a volcano 3 times higher than Everest. On the surface of Venus, beneath roiling clouds of sulfuric acid, mountains rise from the rocky surface. And circling the sun at the very perimeters of our solar system, dwarf planets made of rock and ice. But one planet remains an enduring mystery for even the most advanced telescopes. Saturn and its enigmatic rings. Galileo was the first to see that this planet was different from the rest. For him, the strange features he observed looked like ears. He presumed they were moons. Later astronomers saw them as a vast flat ring encircling the planet. Then, one man discovered that this ring was in fact made up of several concentric rings. That man was astronomer Giovanni Cassini. Now, a mission named after him is investigating why Saturn has rings at all and what they're made of. NASA's Cassini mission.
3, 2, 1, and liftoff of the Cassini spacecraft on a 1 billion-mile trek to Saturn.
In the nose cone of this rocket is the space probe, Cassini. Ahead is a 2 billion-mile journey to the planet Saturn. On board the probe are sophisticated telescopes. They will investigate Saturn's mysterious rings by traveling as close to them as possible.
Good solid rocket booster separation. First stage ignition. 152.
As Cassini heads for Saturn, the furthest planet in Galileo's solar system, it uses the massive gravitational pull of Jupiter as a boost to slingshot it out millions of miles towards its destination.
In the world of telescopes, Cassini has some of the fastest moving telescopes in the solar system, going by at Jupiter at something like 70,000 miles per hour.
Even at such tremendous speeds, the journey still takes 7 years. But finally, Cassini approaches Saturn, 934 million miles from Earth. It dives through Saturn's outer rings to enter orbit around the planet. These are some of the images Cassini takes of the rings. They may look solid, but they are made up of billions of chunks of ice and rock, ranging in size from a grain of sand to the size of a house. And they are spread over hundreds of thousands of miles. But where is all this stuff coming from? Cassini's telescopes reveal that the inner rings are made up of material blasted off the surfaces of Saturn's moons by meteorites. But the furthest visible ring from Saturn is still a mystery. This image taken by Cassini shows that unlike the innermost rings, the outermost ring is a ghostly mist of microscopic particles. Astronomers suspect that the icy moon Enceladus could be where the mist is coming from. But until now, no one has been able to work out how. Then, Cassini's telescopes see something never observed before. Vast plumes of vapor streaming from fissures in the surface of Enceladus.
These plumes go up hundreds of kilometers. That's pretty exciting to find erupting out of an icy moon.
Could these plumes be the source of the outer ring? To find out, Cassini's telescopes do something extraordinary. They fly through the plumes and taste the vapor with onboard detectors.
That's a spectacular thing to be able to do, to be able to tap the interior of an icy satellite.
Back at Mission Control, astronomers analyze the data streaming in. The vapor pouring out of Enceladus is made up of ice, salt, and ammonia. It is exactly the same material as the outer ring. It can only mean one thing. Enceladus's plumes are the source of the misty ring. This is a major discovery. Cassini's spaceborne telescopes are solving the mystery of Saturn's rings that has plagued astronomers for centuries. Telescopes today are journeying deeper into space and searching further to discover secrets that Galileo could never have imagined. But to capture pristine images like these, telescopes had to undergo a dramatic evolution. Back in the 1650s, the first step in this evolution was going to great lengths, quite literally.
Telescopes became very long, 15, 20 feet.
The problem with early telescopes was fuzzy images. The reason? The shape of the lens. As NASA astrophysicist Kim Weaver demonstrates, when a strongly curved lens bends or refracts beams of light, the light doesn't all come to a single point.
First of all, the different beams of light don't line up, and so the image that you get with this lens would be really fuzzy. Also, some of the light has its colors split out, and that distorts the image.
The only way to minimize the blurriness and the rainbow colors is to use thinner lenses with a shallower curve. Because the light comes to a focus further from the lens, refracting telescopes get longer and get greater magnification. 17th century astronomers make ever thinner lenses and space them further apart.
By about 1660, telescopes have magnified 50 or 100 times, and those lengths increased and increased and increased.
This is the first space race. On the quest to see ever further, telescopes reach absurd proportions, up to 150 feet in length, half the length of a football field. These unwieldy telescopes are better, but astronomers want to see even more detail, and these telescopes don't eliminate the rainbow colors altogether. Then, one of science's greatest minds sets out to solve the problem: Isaac Newton. He takes a look at light itself.
Newton found that white light was in fact composed of all these different colors, the colors of the rainbow.
As white light passes through a glass prism, it bends or refracts, breaking up into the colors of the rainbow. This was the root of the astronomer's problem. 8 stories high slide apart. These twin eyes are preparing to look into deepest space. They belong to the Large Binocular Telescope. It is one of the most powerful telescopes on Earth, costing over $120 million. These 28-foot wide mirrors collect light from objects millions of times fainter than anything our eyes can see. 600 tons of machinery turn the mirrors to look more than 13 billion light years away, to the very edges of the visible universe. Super telescopes like this are taking real images that illuminate the darkest corners of our skies. Billowing clouds of gas and dust are buffeted by supersonic winds and lit up by thousands of energetic new stars. 57 trillion miles high, these giant clouds of gas and dust are stellar nurseries, hiding the very birthplaces of stars and planets. Suddenly, a star's explosive death sends its superheated gas ripping through space at hundreds of miles per second. And in faraway galaxies, we can take images of invisible jets of energy screaming out from one of the most mysterious objects, a supermassive black hole. All because of high-tech telescopes.
The telescope has changed the way we as a species think about ourselves.
With a new telescope, you're always going to find something new because you always add to your ability to see more.
These breathtaking images are only possible because extraordinary telescopes like these are staring out night after night across the globe and in space. Over the past 4 centuries, revolutions in technology have transformed this groundbreaking instrument. So where did it all begin? The journey starts with one man and 2 pieces of glass. It is the summer of 1609. Mathematics professor Galileo Galilei is building his own version of an extraordinary new invention. It is the telescope, a name that means far-seeing